lesson. Okay, so let's start. So this is pair annihilation. Due to some problem, I have not written. This is pair, P-A-I-R, annihilation, A-N-N-I-H-I-L-A-T-I-O-N. Is it visible?
Yes, sir.
Yes, sir.
So pair annihilation. This annihilation means destruction. D-E-S-R-U-T-C-T-I-O-N. That means pair means two. When one antiparticle mutually interact, so what will happen? One particle and its antiparticle mutually interact. So what will happen? The pair will be destroyed. So there will be no this pair. The pair will be destroyed, and due to destruction of the pair, we can get the energy. We are getting the energy. Okay? We are getting the energy. So this phenomenon is called as pair annihilation. Okay? Okay?
Yes, sir.
Yes, sir.
Okay. So we have to take one example. Be quick. You have to write. This is electron. If electron combines with its antiparticle, that is positron. This is positron. Then we can get the photon or gamma ray. The energy of the photon is equal to, you can write photon. So write, electron combines with the positron, we are getting the photon. That means, if I can write, electron means E minus, positron means E plus. You see, so positron means antiparticle means having same mass, charge is opposite, we are getting the energy. The energy is equal to h nu. Okay, so this is the equation. Are you writing or not?
Yes, yes, sir.
Yes, sir.
Yes, sir.
So the electron combines with the positron, we are getting the photon having energy E is equal to h nu. Okay, so if I want to will show diagrammatically, let's take this is say positron. This is a positron, and this is one electron. Electron means minus. Okay, electron combines with the positron, we are getting this gamma ray or photon. This is photon, or we can say gamma ray. Okay, so this is electron E minus, this is positron E plus. E minus combines with the E plus, we are getting the gamma ray. Gamma ray means this is the photon. Photon means energy is equal to h nu. Okay? Okay?
Yes, sir.
Okay.
Yes, sir.
Yes,
Yes, sir.
Okay. Okay, next I want to turn the next page. So next is, so what is the energy of the photon? Just yesterday I told you 1 gram of atom bomb destroyed both the cities of Hiroshima and Nagasaki. So how energy, that means how energy will be converted from matter and vice versa. Okay, so right, the energy of each photon, so we are getting one electron combines with one positron, we are getting the photon. So what is the energy of each photon? That equals to the rest energy of the electron. This is rest energy of the electron. Okay, what is the rest energy of the electron? As said by Einstein, E is equal to mc square. M0 into c square. What is the M0? M0 is known as rest mass of the electron, which is equal to 9.10⁻³ kg. Okay, all of you know what is the mass of the electron?
Yes, sir.
yes, sir. Yes, sir.
Yes, sir.
9.1 into 10⁻³ kg. What is the C value? What is C? Who can say?
Speed of light.
Speed of light.
3 into 10 to the power 8 meter per second square whole square. Okay, 3 into 10 to the power 8 meter per second whole square. So if you calculate, we can find this is 0.51 mega electron volt, because you know what is the unit of the energy? The unit of energy is joule or erg. But in quantum physics or atomic physics, we have to express in terms of electron volt. Okay, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Just imagine if one electron interact with one positron, the pair will be destroyed, and 1 gram of atom bomb destroyed the two cities. Just imagine how much energy were present inside 1 gram of atom bomb. Okay, so since each atom, that means each matter consists of n number of atoms, and there are n number of electrons are present and n number of positrons are present. So just imagine how much energy we are getting. Okay, okay, understood? So this is known as pair annihilation. Okay, Samya, understood?
Yes, sir. Yes,
Okay.
sir.
So next, write pair production. So many more things are there, but as per your syllabus, we are discussing. Okay, so this is pair production. So that was pair annihilation. This is pair production. So just opposite. Okay, just opposite of pair annihilation is known as pair production. Okay, okay. So right, when a high frequency gamma ray is incident. So right, when a high frequency, this is just a reverse of the pair annihilation. When a high frequency gamma ray, when a high frequency gamma ray is incident on a atomic nuclei, on a atomic nuclei, then when a high frequency gamma ray is incident on an atomic nuclei, then some gamma rays are converted into electron and positron pair. Electron positron. This phenomenon is called pair production. This phenomenon is called pair production. Understood?
Sir, एक बार
Yes, sir.
gamma rays are converted into
Ashirbad, are you there? एक बार रीड करो, क्या सेंटेंस लिखा है, रीड करो. Very good. Okay. So when a high frequency gamma rays is incident on an atomic nuclei, then some gamma rays are converted into electron positron pair, PAIR pair. This phenomenon is called pair production. Okay. This is one atomic nucleus. The plural of nucleus is nucleus. This is the gamma ray. One gamma ray is coming This is gamma ray. When gamma ray is incident on a atomic nucleus or atomic nuclei, then what will happen? The nucleus, some of the gamma rays are converted into electron and positron pair. So from this atomic nuclei, electron and positron will be evolved. This is electron, this is positron. So here the electron positron pair will be produced. So this phenomenon is called pair production. Okay. So I can write from the gamma ray, that means from the gamma ray I am getting electron plus positron. Okay. Or I can write gamma ray, I can write electron means E minus, this is E plus. Okay? Okay. Okay, understood?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So for some of the MCQ based questions are, you can note down. It is an example of conservation of energy and momentum. It is an example of conservation of energy and momentum. Okay. So one question was asked, in pair production, conservation of dash and dash occurs. What will be your answer? Conservation of
Energy and
momentum.
Energy and momentum.
Very good. Yes, everybody, you have to remember, you underline conservation of energy and momentum. Okay. Next point, right? The suitable condition for this process is H nu is greater than equal m0 into c square. This is the condition. That means for pair creation, for pair production to take place, h nu must be greater than equal twice of m0 into c square. Okay? So don't think that the nucleus is split into electron and positron pair at any frequency. We have to apply a high frequency, and the condition will be h nu, that means the frequency of the gamma ray or the photon having frequency nu will be must be greater than or equal twice of m0 into c square. Otherwise, there will be no pair creation occurs. Okay? समझ में आया? Okay.
Yes, sir.
So these are the 2 points you have to remember. Okay. Next. As I said, it will take place a high frequency. The frequency. This is a high frequency of electromagnetic radiation. So next we have to discuss De-Bruggle hypothesis. Okay. So as I said, we are discussing the particle aspects of the radiation. So we discussed the photoelectric effect, we discussed the Compton effect, and this is also pair creation and the pair production. We are seeing that the particles are present, electrons and positron particles are produced. In case of pair destruction, electron positron pair are destroyed. Okay. So next, write De-Bruggle. So De-Bruggle means DE small d BROGLIE. De-Bruggle hypothesis. Hypothesis. What will happen? So look here. we completed the particle aspects of the radiation. Okay. So now up to pair creation, we discussed the particle aspects of the radiation, and now it is wave nature of the particles. Okay. So this is wave nature of the particles. So the wave nature of the particles was first demonstrated by Louis De-Bruggle and was later verified by the experiment. Okay. So in 1924, Louis De-Bruggle proposed that all material particles are associated with waves, and that waves are called matter waves or De-Bruggle waves. Okay. So right in 1924, okay, परिचय समझ में आ रहा है? So up to pair, you see, we discussed the black body radiation, photoelectric effect, Compton effect, pair production, pair destruction, all are particle aspects of the radiation. So now from the De-Bruggle hypothesis, we have to discuss the wave nature of the particles. Wave nature of the particles. Okay? Hello?
Yes,
Am I
sir.
audible?
Yes, sir.
Yes, sir.
Yes,
Okay.
Yes, sir.
Okay. So right, in 1924, Louis De-Bruggle, Louis, Louis Broglie, Louis De-Bruggle proposed that all material particles are associated with in 1924, Louis De-Bruggle proposed that all material particles are associated with waves called matter waves or De-Bruggle waves. Okay. So 1924, Louis De-Bruggle proposed that all material particles are associated with waves. All material particles are associated with waves, and those waves are called as in nature. Okay. So next point, right? Let me turn the page. Right. We have to discuss here the different forms of De-Bruggle wavelength. Okay. So derivation is not required as per your syllabus. You have to find the De-Bruggle, B-R-O-G-L-I-E, De-Bruggle wavelength. Since he said that all moving object, that means all materials, all objects have the wave in nature. So what will be the wavelength? De-Bruggle wavelength. So these formula are very important. For numerical based question, you have to remember De-Bruggle wavelength. Since wavelength means lambda, okay. So we have to write in different forms. Okay. Number one, in terms of linear momentum. Okay. In terms of linear momentum, right? In terms of linear momentum. What is a linear momentum symbol? Who can say? Linear momentum means P. P with the linear momentum. Yes. He said that for a particle of mass m and velocity v, we can say the linear momentum is equal to mass into velocity. So lambda is equal to, this is lambda, this is De-Bruggle wavelength, lambda is equal to h by p, or lambda is equal to h by m into v, h into m into v. So v for velocity or mass in terms of kinetic energy. That means for a non-relativistic free particle of kinetic energy E, we have in terms of kinetic energy. In terms of kinetic energy, lambda is equal to h by, please mute, h by 2m into E. This is E for energy. Okay, E for kinetic energy. Okay, or you can write Ek better. Okay, so lambda is equal to h by 2m into Ek. So here Ek is known as kinetic energy. Okay, कौन किछ कहू ना कौन?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Next, in terms of potential, in terms of potential difference, potential difference. So you know potential difference or the potential are same. Potential difference, I can say the symbol as small v. Okay. So a charged particle of charge q and mass m, which moves through a potential difference small v, then lambda is equal to, here the formula lambda is h by under root 2m q into small v. So here v with the potential difference, small v. I have taken capital V for velocity, here small v for potential difference. Okay. So m is mass, q be the charge. So here q be the charge. Okay. Number 4. Number 4, in terms of temperature, in terms of temperature. So be careful, the derivations are not required, but formula based question. Temperature means T. He said that in this case, suppose a large number of particles, each of mass m, are in thermal equilibrium at absolute temperature T, then so what will happen? Your lambda will be h by under root 3m k into T. Okay, lambda is equal to h by under root 3m into k into T, where k is known as Boltzmann's constant. Boltzmann's constant, and m be the mass, T for temperature. Okay, so the last point, for a free relativistic particle, free relativistic VISTICK, for a free relativistic particle. So what will happen? Here the formula will be lambda is equal to hc by e square minus m0 square c4. Okay, so E be the total energy. The formula is this. Lambda is equal to h into c. H be the Planck's constant, c be the speed of the light, E be the energy, m0 be the rest mass of the electron, c be the speed of the light. Okay, so here m0 be the rest mass of the electron, which is equal to 9.1 into 10 to the power minus 31 kg, and c be the speed of the light in Vacuum 3 into 10 to the power 8 meter per. No, H is equal to, already I told, 6.62 into 10 to the power minus 34 joule into second. Okay. So only informations you require E, energy. Then the question will be asked, what will be the De-Broglie wavelength for a free relativistic particle? So there will be confusion. If energy is given, many students applied this formula, lambda is equal to h by 2m into ek. So this is wrong, because here ek means kinetic energy should be given, but here the question is for free relativistic particle. This is the formula. This is for non relativistic free particle. Okay, understood?
Yes, sir.
Yes, sir.
Okay. So accordingly, these are the all formula based numerical you have to solve. Okay. So Ruturaj Lenka,
Yes, sir.
Ruturaj Lenka, are you there? So tell me, if mass and velocity of the particles are given, how we have to determine the de Broglie wavelength?
Sir, lambda is equal to h by mb.
Very good. Okay. Next question is Hassan Raja. Mass of the particle is given, kinetic energy is also given. So which formula you have to apply? Hassan Raja. Aditya Kumar.
Yes, sir. Lambda is equal to
Tell me the
h by
answer.
root over of 2m ek, where ek is the kinetic energy.
Very good. Okay. Next, Subhalakshmi Behra. Suppose the mass of the particle, mass of its mass, and the potential difference, all three are given. So which formula will be applicable? Subhalakshmi.
So lambda is by root over 2m qv.
Are you listening?
Yes, sir.
Suryamai.
Yes, sir.
So who gave the answer? Who gave
Sir,
the answer? Okay, very good. So lambda is equal to h divided by 2 into m into q into potential difference. Okay. Next, Avinash. If temperature is given, Boltzmann constant is given, mass is given, and the particles are present in thermal equilibrium. Which formula? Avinash, are you listening? No.
Sir, it's Ashirvad, sir, not Avinash.
Yes, Asilbad. Tell me the answer. Boltzmann constant. So this will be given to your question. Okay. Okay. Next, Chinmay Behra. Chinmay Behra, are you there? No. Pragya Paramita Chaudhary.
Yes, sir.
Question is, for free relativistic particle, energy is given. Okay. The rest mass of the proton is given. Rest mass of the proton is given. So which formula you have to apply?
Lambda is equal to sc by root over of e square minus mg square c4.
No. So not m0, you have to write here mass of the proton, because I told you the mass of the proton means you have to take the mass of the proton here. That is 1.67 into 10 to the power minus 27. If electron is given, you can apply this formula, mass of the electron. Okay? Pragya, understood?
Yes, sir.
Okay, nice. So this is all about the De-Broglie hypothesis, and this will be, you can find from the Google, that is, I have forgotten the value, 1 point, that is, just 1 minute, I can say you, 1 point, That is some like that, because we have to express here in terms of temperature. That is okay. You can find from the Google. Okay, otherwise I shall tell you. Okay, I have forgotten the value.
That is
Okay.
1.38 into 10 to the power minus 23 joule per Kelvin.
Minus 23 is given.
Yes, sir.
1 point how much?
1.38.
1.38, yes, 1.38 into 10 to the power minus 23 J by K, joule per joule divided by Kelvin. Okay. Boltzmann constant is called as matter wave or De-Bruggle wave. Okay. So next is Heisenberg, Heisen, Heisenberg uncertainty, 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 Nity, uncertainty. Not a I there. Uncertainty principle. Heisenberg uncertainty principle. This is HUP. In short, I am saying. Okay. Heisenberg uncertainty principle. Okay. Just 1 minute. So this is just you see. We are discussing the quantum physics. 1924, Louis De-Bruggle came to the picture. Now, in 1927, this is the year, in 1927, the physicist Heisenberg, this is Heisenberg, proposed a very important principle known as uncertainty, CERTAINTY, not I is present here. Okay. So Heisenberg proposed a very important principle which is known as uncertainty principle. Okay. So actually what will happen in quantum physics or in quantum mechanics, we are discussing about the particles, the microscopic particles. The microscopic particles are described by a wave packet which moves with group velocity. Okay. So in wave we have to study what is group velocity and phase velocity. So here the particles are described by a wave packet which moves with group velocity, and that wave packet cannot have well defined momentum. We cannot define the momentum. Hence, there is uncertainty about the momentum of the particle. Okay, since the particle may be found everywhere, anywhere within the wave packet, the position of the particle is also uncertain. Okay, so one of the beautiful principle proposed by Heisenberg, he said that one cannot measure simultaneously both position and momentum of a particle. So this is, the name itself means uncertain. Uncertain means not certain. Uncertain, inappropriate, incorrect. Okay, that means simultaneously one cannot measure both position and momentum. Okay, we cannot measure the position and the momentum simultaneously at a time. So if you do this, one value gives you correct, another will be incorrect. So this is the principle of Heisenberg. Understood? Understood or not?
Yes, sir.
Yes, sir.
Okay. So we are saying don't do the work, don't do both the work simultaneously. That means suppose you are in the class, you just joined the class and you are doing some other work. You are busy with your phone, Facebook, Insta, or you are giving like to someone of your friends on Facebook. Okay. So what will happen if you do? You may be your friends, your good friends, Your best friends may appreciate you for your like, your good comment, but that will be correct. But what about your study? Your study will be incorrect. You will not be. You will be not give attention to about your study, so that it will affect your result. Okay. So if one will be correct, another will be incorrect. Okay. Understood? So right. In 19 Heisenberg, जल्दी लिखो मैं in 1927 Heisenberg proposed that one cannot measure simultaneously both position and momentum of a particle correctly. One cannot measure position and momentum of a particle correctly. Okay?
Yes, sir.
Okay. That means if position is measured correctly, that means if position is measured correctly, then momentum will be incorrect. If position is measured correctly, then momentum will be incorrect. Okay? Ruturaj,
Sir,
read the sentence.
in 1927, Heisenberg proposed that one cannot measure simultaneously both momentum and position of a particle correctly. That means if position is measured correctly,
Yes.
then momentum will be incorrect.
Very good. Very nice. So next, right? Mathematically, it states that mathematically, what is the statement? Next, you write the statement. It states that the product of uncertainty. It states that the product of uncertainty in determining the position and momentum of a particle at a given instant is greater or equal to this is the symbol is H cross. You put a bar on H. This is known as H cross by 2. This is known as H cross by 2. You can read as H cross. Okay. You can read it as H cross. And the value is equal to H by 2 pi. Its value is H by 2 pi. H by 2 pi. This is pi. Huh? Okay?
Yes, sir.
Pragya,
Yes, sir.
Yes, sir.
read the statement.
It is stated that the product of uncertainty in determining the position and momentum of a particle at a given instant is greater or equal to h cross by 2. H cross is equal to h by 2 pi.
Very good. So you know H is Planck's constant, pi is equal to 3.141. If you take the ratio, so that ratio is a constant named as H cross. Okay. So Heisenberg mathematically said that if you take the multiplication in determining the position and the momentum of a particle, then your result, the product, either greater or equal to the h cross by 2, but not less than. Okay. So everybody, have you written or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
sir.
Birpal. Yes, Birpal. Yes, Birpal. Taufik. Tejas Singh.
Yes,
Tejas Singh, have you written or not?
yes, sir, written.
Very good. एक बार read करो statement.
It states that the product of uncertainty in determining the position and momentum of a particle at a given instant is greater or equal to h cross by 2.
H cross by 2. Okay. So next, very good. You write that means del x into del p. X for position, p for momentum is greater than or equal to h cross by 2. So this is the mathematical statement of Heisenberg. Del x into del p greater than or equal to h cross by 2, where del x is known as uncertainty. We don't see uncertain, not sure. Uncertainty, EAINTY, uncertainty in position. And del P is known as uncertainty in momentum. Uncertainty in momentum. Okay. So this is the del x, del p, the value is equal to greater than or equal to h cross by 2. Similarly, if you take for energy, it has also been seen that we cannot measure energy and a time simultaneously. One will be correct, another will be incorrect. Del E multiplied with time, del T greater than equal to h cross by 2. And another will be incorrect. All of you know the linear momentum. This is angular momentum. The angular momentum means J. J for angular. Hello? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, del J into del theta is greater than equal to h cross by 2. Okay. So the three informations we got as proposed by Heisenberg, we cannot measure position and momentum simultaneously. We cannot measure energy and time simultaneously. We cannot measure angular momentum and angle. Angular momentum is del J we have taken. Okay. So as per your syllabus, so you will find the numerical based question. If del x is given, what will be del p? You apply the formula. So del p is equal to h cross by 2 into del x. Okay. So next, the application. The application of HUP. What is HUP? Heisenberg
Uncertainty
Heisenberg
principle.
Uncertainty principle.
Very good. Okay. So as per your syllabus, we have to study two applications. Okay. Some illustrations were there, like Heisenberg's gamma ray microscope. Okay. So diffraction of the electron by a slit. So this part is not here in the new syllabus. We have to only discuss the applications. The uncertainty principle imposes a natural lower bound on the uncertainty product. Okay. So the first application is your ground state energy of number one application. So this is very important long question. Ground state energy, GROUND, ground state energy of linear harmonic oscillator. Okay. Ground state energy of linear harmonic oscillator. Okay. So we have one harmonic oscillator, means the object which is in simple harmonic motion. We can say that is harmonic oscillator. Okay. So we are able to find what is the ground state. Ground state means the minimum energy possessed by the oscillator. That is your ground state. The lowest energy level is known as ground state. So look here, your classical physics said that this is the ground state. This is the ground state. These are the excited state, next excited state, like this. So this is the ground state, means the energy is equal to E0. Similarly, E1, the various energy levels are there. Your classical physics said that the ground state energy oscillator is 0. But quantum physics said that it is not equal to 0. So here it is a contradiction between classical physics and quantum physics. Okay. Now, since we are discussing the quantum, I'm going to explain, we are going to determine what will be the ground state energy of the linear harmonic oscillator. So all of you mark, it is very important long question. Okay. So you can write total energy of, we have to do the derivation, total energy of linear, this is linear harmonic oscillator is, so already you have studied in module 1 what is the total energy of the simple harmonic oscillator, that is total energy is E is equal to potential energy plus kinetic energy. Am I right? The total energy is equal to potential plus kinetic. What is the formula for potential energy? What is the formula? Half m
omega square x
square. What is the kinetic energy? What is the kinetic energy? Half m v square. Half mv square. So I want to write in terms of momentum. This will be p square by 2m. Understood? P is equal to m into v. So 1 m cancel. So this will be half mv square. Just I have written. Okay. So that means I can say the energy is equal to p square by 2m plus half m omega square. The name, the symbols already you are acquainted. X for position, m be the mass, omega be the angular frequency. Okay. Okay, understood. So here x be the position, x be the position of the particle, SITION, m be the mass, p be the momentum, linear momentum, p be the linear momentum, omega is angular frequency. Omega is known as angular frequency. Okay. So
Yes, sir.
we got the total energy. I am going to determine what is the ground state energy, and I have to apply which principle? Heisenberg Uncertainty principle. Okay. So right, according to HUP, Heisenberg or equal. So I have taken, let it is nearly equal to, we can take greater than or equal, na? Del x into del p is equal to h cross by 2. So this implies, let del x is equal to x, del p is equal to p is equal to h cross by 2. Okay. So here I have taken one assumption. So next, right, let me turn the another page. Okay. So from this equation, what will be the value of p? We can say p is equal to x, p is equal to h cross by 2, p is equal to h cross by 2 into x. अरे मिला ना नहीं? So p is equal to h cross by 2x. This is equation number 2. बुझेला? अरे x p
Yes,
is
sir.
Yes, sir.
x p is equal to h cross by 2. So p is equal by 2x. Okay. Okay. So p is equal to h cross by 2 into x. So I have to stop here because I have another class at 12:45.
सर
हाँ.
सर इंटरनल एग्जाम में कहाँ तक आएगा फिजिक्स?
तुम्हारा इंटरनल शायद 4 तारीख को है ना?
Yes,
सीरियल नंबर 1 अभिनंदन, आदर्श विश्वाल.
Yes, sir.
सब give attention to your roll call. नेक्स्ट टाइम बोलेंगे तो मैं नहीं देंगे अटेंडेंस. आदित्य,
Present, sir.
आलोक, अमन,
Yes, sir.
अमित, अजित, अरुण,
Present, sir.
आशीर्वाद, आशुतोष, आशुतोष, हेलो, आशुतोष,